Alright everyone, welcome to Talk GCSE. Let's start from the basics. What actually is covalent bonds? Now, a covalent bond forms when two nonmetals share a pair of electrons. Now, the key word here is share. In ionic bonding, electrons are transferred. One atom loses, the other one gains. But in covalent bonding, the atoms share electrons. Now, why do they do that? Because atoms want to become stable, and in chemistry, stability usually means having a full outer shell of electrons. Most atoms are trying to get a full outer shell, either 8 electrons or 2 if we're talking about hydrogen. So imagine 2 hydrogen atoms, each hydrogen has 1 electron, so they both need 1 more to fill their outer shell. Instead of one atom giving an electron away, they share the electrons. So now both hydrogens count 2 electrons in their outer shell, and the one they brought, and the one they shared. That shared pair is what forms the covalent bonding. Now, if one pair of electrons is shared, we call that a single bond. If 2 pairs are shared, that's a double bond. 3 pairs, well, that's a triple bond. The more pairs shared, the stronger and stronger the bond becomes. That's why nitrogen gas, which has a triple bond, is very stable and doesn't react easily. So remember this for exams. A covalent bond is a shared pair of electrons between non-metal atoms formed so each atom can achieve a full outer shell. Now let's look at some common examples, because this is where students usually start recognizing patterns. Take water, H2O, oxygen needs 2 more electrons to fill its outer shell. Each hydrogen needs 1, so oxygen forms 2 single covalent bonds, 1 with each hydrogen. Each bond is one shared pair of electrons. Next, if we talk about O2, each oxygen atom needs 2 electrons to complete its outer shell, because remember it's in group 6, that means 6 electrons in the outer shell, so it needs 2. So they share 2 pairs of electrons, and this gives us a double bond. Now, same with N2 nitrogen gas. It's even stronger actually, because each nitrogen needs 3 electrons, so it's a triple bond, very strong, very stable. Some more examples are things like methane, carbon dioxide. Now, here's something important actually that we need to know. These are called simple molecular substances. Inside each molecule, the covalent bonds are strong, but the forces are actually weak. These are called the intermolecular forces. So now that difference, strong bonds inside, weak forces between them, explains a lot about their properties, especially melting and boiling point. Now, this is where students often get confused, because not all covalent substances behave the same way. First, because simple molecular substances have low boiling and melting point, because when you melt them, you're not breaking the covalent bonds inside them, you're breaking them because they're strong. You're only overcoming the weak molecular forces between them. So that doesn't require much energy. They also don't conduct electricity. Why? Because they don't have free moving charged particles, no free electrons, no ions. Now, if we compare that to giant covalent structures like diamond or graphite, in these substances there is no separate molecule. Instead, you have a huge network of atoms all bonded together by strong covalent bonds. Imagine like one massive structure. Because you have to break strong covalent bonds to melt them, they have a very high melting point. Diamond is extremely hard because every carbon atom forms 4 strong covalent bonds in a rigid 3D structure. Graphite is different because each carbon bond to 3 others, forming layers. Now those layers can slide over each other, which is why graphite is soft. It also conducts electricity because it has a delocalized electron that can move. Then we have polymers. These are long chain of repeating units. The covalent bonds along the chain are strong, but the forces between the chains, as talked about before, are weaker. That's why many polymers can actually stretch and bend. So the key idea is structure determines their properties. If we talk about the exam skills that you need to know, First rule is use the phrase shared pair of electrons. Examiners love that phrase. If a question asks why covalent substances have low melting point, you must just say weak intermolecular forces between molecules require little energy to overcome. If it's about giant covalent structures, you say strong covalent bonds throughout the structure require a lot of energy to break. If they ask about electrical conductivity, always mention things like delocalized electrons, are they there or they're not there, so they're free to move. Be specific. What you want to avoid is like vague answers like strong bonds, unless you say whether they are intermolecular bond or intramolecular bond. So what are you talking about? You need to be careful and specific. Now, finally, always link the structure of the property. Don't just state facts, explain the reason. That's what pushes the answer to a higher mark. If you found this useful, guys, just make sure to give me a subscribe on Talk GCSE. Thank you.